section, parametric curves and polar.
मैम आपने कल आपने
curves.
बताना था मैम, वो हॉरिजॉन्टल और वर्टिकल आपने बताना था कल।
जी वो बताना था, तो मैं यही तो पूछ रही हूँ कि अब तक हमने क्या किया, उस तरफ भी आते हैं। अब तक हमने जो नया सेक्शन स्टार्ट किया अपना सेकंड सेक्शन, parametric curves and polar coordinates. What we have done in parametric curves so far? So far you have learned what are parametric curves, why there's a need to represent curves in the form of parametric equations, how we sketch parametric curves, how we can find the equations for a parametric curve, and then in the last class you did how to find tangent line to a parametric curve. So what's the procedure to find equation of a tangent line to a curve? The procedure is parametric curves are in this form: x is equal to f of t, y is equal to g of t. So when you have to find the equation of a tangent line, you have to find the slope dy by dx at t is equal to the given value. That is, you have to find by using chain rule dy over dt and dx over dt, and then put t is equal to the given value. The equation of a straight line is given as y minus y1 into y minus y1 is equal to m into x minus x1, where this slope is this given by this if it's the equation of a tangent line, and this y1 and x1 could be given or it could be found by putting the value of t, given value of t, in the equation and find in the parametric equations these f of t and g of t, right? This is how you will find the equation of a tangent line. Now, in order to find the points where the equation of the tangent line is horizontal, it means you have to put this dy by dt is equal to, for horizontal tangents, dy by dt is equal to 0 and dx over dt is not equal to 0. These conditions are for horizontal tangents. And for vertical tangents, dx over dt is equal to 0, where dy by dt is not equal to 0. Right? Now, we have to complete the part B of this example 2. At what points is the tangent horizontal? When is it vertical? So for this we need dx over, I'm doing the B part. For this you need dx over d theta, which is r is a constant, 1 minus cos theta, and dy over d theta is equal to r minus cos theta. Derivative of minus cos theta is sine theta, right? Now for the horizontal tangents, dx over d theta should equal to 0. This implies that r 1 minus, you will put dx over d theta equal to 0. R cannot be equal to 0. So this implies that cos theta is equal to 1. So theta is equal to, what is theta when cos theta is equal to 1?
pi by 2.
I'm 0
0 is the multiple, odd or even multiple? No. For horizontal tangent, you have to put dy over d theta is equal to 0, not dx over d theta. Dy by d theta is r sine theta is equal to 0. Sine theta is equal to 0. This implies that theta is equal to what? Theta is equal to multiple of pi, any integral multiple of pi. N can be 0, plus minus 1, plus minus 2, plus minus 3, up to so on. Again, we have to exclude those points for which dx over d theta is equal to 0. For this point, dx over d theta should not be equal to 0. So dx over d theta, that is 1 minus cos theta is equal to 0, implies that cos theta is equal to 1. So theta is equal to what? What are the values of theta? Multiple of pi? No, it is even multiple of pi. For odd multiples of pi, cos theta is equal to -1. So we have to exclude all the values of theta for which cos of theta is equal to 1. So this implies that theta should equal to even multiples of pi only, because we have to exclude all those points for which dx over d theta is equal to 0, and dx over d theta is equal to 0 mean cos theta is equal to 1. It means theta is equal to the even multiple of pi. So we have to exclude the even multiples of pi. We have to take only odd multiple of pi. So theta is equal to 2n minus 1 n pi, where n is 0, 1, 2, plus minus 1 plus minus 2. So what would be the point then? Put this value of theta in this equation. In this equation, put the value of theta. You will get x is equal to 2n minus 1. Sorry, this is not n. Pi r. And what is the value of y? When you put theta is equal to 2n minus 1 pi in this equation, what is the value of y? What is the value of y?
2r.
It is 2r. So at the point 2n minus 1 pi r and 2r, these are the points where the tangent line is horizontal to the curve C, to the cycloid C. Do you know the figure, the sketch of the graph of the
मैम
cycloid?
मैम मैम जहाँ से आपने ये थीटा किया ना मैम, यहाँ से समझ नहीं आई, जहाँ से आपने थीटा को किया ना वहाँ से प्लीज दोबारा बता दें
ये this one. So for horizontal tangent,
मैम।
you have to find, मैं
जब
वही
आपने
बता रही
किया
हूँ,
थीटा इक्वल टू 2n माइनस 1 वाला
dy
वो वाला
by dy by d theta is equal to 0, and dx over d theta is not equal to 0. First of all, you have to understand this condition, these two conditions. These two conditions are for horizontal tangent. That is, dy by dx is 0 only when this quantity is 0 and this quantity is not 0. Otherwise, it would be 0 over 0 form.
सही है
dy by d theta is 0. It means r sine theta is 0. That is, sine theta is equal to 0. Theta is equal to n pi, and dx over d theta should not equal to 1, mean 1 minus cos theta should not equal to 1. So cos theta is equal to 1 when theta is the even multiple of pi. So you have to exclude the even multiple of pi, because you have to take only those points for which dy by d theta is equal to 0 and dx over d theta is not equal to 0. तो वो थीटा की सारी वैल्यूज निकाल के उनमें से वो आपने वैल्यूज इसमें से एक्सक्लूड करनी है जिसके लिए ये इक्वल टू 0 आ रहा है, यानी कि 1 के इक्वल आ रहा है. 1 के इक्वल कब आता है? जब ये ऑड इवन मल्टीपल हो. तो यहाँ पे सिर्फ फिर इवन ऑड मल्टीपल रह गए. इट मीन्स थीटा इज इक्वल टू 2n minus 1 pi. ओके,
सही है मैम।
चलें जी, ये आ गया और पॉइंट्स भी आ गए. नाउ इफ यू रिमेंबर द ग्राफ ऑफ द साइक्लॉइड, this is the shape of the cycloid. It starts when theta is equal to 0. So this point, at this point, it has horizontal tangent, horizontal tangent, horizontal tangent, horizontal tangent at these points. And these points are basically when I put n is equal to 1, this point is, these points are 2n minus 1 pi r 2r. These are the points where the tangent line is horizontal. When I put n is equal to 1, I will get pi r. So this point is pi r 2r. So what about this point? When I put 3 pi r 2r. This is 5 pi r 2r. This height remains the same. Only the x coordinate is changing. Right? Now, what about the vertical tangents? Can you see the vertical tangents? Can you see the vertical tangents? Do the curve have vertical tangents?
Yes, ma'am.
Where?
0, 2 pi r
At 0,
0,
at
2
this
pi.
point 2 pi r, at 4 pi r, and 6 pi r, even multiple of pi r. Okay, for vertical tangents, you can see dy by dx should equal to, it should be infinite. It means dy by d theta is not equal to 0 and dx over d theta is equal to 0, so that you will get infinite dy by dx. So dx over d theta should equal to 0. And dy by d theta should not equal to 0. Dx over d theta is r1 minus cos theta is equal to 0. And this is r sin theta is equal to 0. Cos theta is equal to 1. This implies that theta is what? 2 and pi. And this implies that sin theta is equal to, means theta is equal to what? N pi. Theta should not equal to n pi. No. कौन से पॉइंट्स लेंगे इस केस में हम? Theta is equal to 2 n pi, and we have to exclude all the points when theta is a multiple of pi. Means there is no vertical tangent. What does it mean?
मैम हम इवन मल्टीपल्स लेंगे थीटा के.
Even multiple अगर लेते हैं तो in that case sin theta is equal to 0. और अगर odd multiple लेंगे तब भी sin theta 0 आ रहा है. तो sin theta को 0 नहीं होना चाहिए, otherwise आपकी 0/0 फॉर्म बन रही है.
L'Hopital rule लगा देना.
Basically now we will find dy by dx. Is it infinite or is it 0/0 form? So for this we will not put dy by d in dy by dx. We will not put theta is equal to 2 n pi. Instead we will take the limit theta approaches to 2 pi n from the right side. It is equal to limit theta approaches to 2 pi n plus, now dy by this is sin theta over 1 minus cos theta. Now this is 0/0 form, so I will apply the L'Hopital rule. Limit theta approaches to 2 pi n plus, derivative of sin theta is cos theta, and derivative of 1 minus cos theta is sin theta. Now what is the limit of this expression cos theta over sin theta when theta approaches to 2 pi n plus?
Infinity, ma'am.
Infinite, positive or negative?
Positive, ma'am.
Positive, how? Theta approaches to 2 pi n plus from the positive side, from the right hand side. It means theta lies in the 2 pi plus values of theta lies in which quadrant? 2 pi plus values
Third
lie
quadrant.
in the first quadrant.
Third quadrant.
First quadrant, first.
Sorry.
2 pi plus. It lies in the first quadrant. So in first quadrant, both cos theta and sin theta are positive. So they will approach to positive infinity. So this means the derivative dy by dx is plus infinity at these values. At theta is equal to 2 pi n. So now we will find the left hand limit. And for the left hand limit, we will check whether it's infinite or not. If it is other than infinite, it means the limit does not exist. So we have to take limit of theta approaches to 2 pi n from the negative side. Sin theta by 1 minus cos theta. And now putting the limit, and theta approaches to 2 pi n minus. The values of theta are now less than 2 pi. So the theta lies in which quadrant? It lies in the fourth quadrant. In the fourth quadrant, cos theta is positive and sin theta is negative. So you will get minus infinity over here. Again, in infinite slope. So it means the tangent line lies at these points. 2 pi n. So we will put 2 pi n. This is your solution. 2 pi n in x. X is equal to r theta minus sine theta. So you will get 2 pi n r, and y is equal to r 1 minus cos theta. When I put theta is equal to 2 n pi, I will get, what will I get? 1 minus, when cos theta, cos of 2 and pi is 1, so 1 minus 1 is 0. I will get 0. So the points where the tangent line is horizontal, is vertical, is 2 pi n r and 0. That is 2 pi r, 4 pi r, odd multiple, even multiple of this 2n, 4 pi r, 6 pi r, and all these. This is how you will find the equation for a vertical tangents. That is, if both are 0, so you will check dy by dx. Similarly, if you get horizontal tangent and both the derivatives with respect to theta or with respect to t are 0, then you will cross check this expression. For horizontal tangent, this must be equal to 0. Both of the left and right hand limits must be 0. And for the vertical tangents, these two limits, left hand and right hand limit of the derivative, is equal to infinity. Okay, समझ आ गई है सबको, या कोई क्वेश्चन है इस रिलेटेड? Okay, now finding how will we find the area under a curve. Y is equal to capital F of x from A to B. You know the formula of area under the curve. Y is equal to F of x. This is the formula for area under the curve. Now we have to convert this formula in in parametric equations. So my parametric equations are x is equal to, for a curve, are x is equal to f of t and y is equal to g of t. The limits of t are, I have to find the area, the limits when t lies from alpha to beta. So my limits of t are from alpha to beta. Now capital F of x mean this y. This is basically my y. So when I put y, value of y is g of t. And what is dx? Dx is taking differential. It is f prime of t dt. So this is the formula for area under our parametric curve. You can also write it in this way in terms of y and x. You will write it y into dx. Put the value of y from here and take the differential by using this equation. Okay, now let's see how to apply this formula. Again, we have to do this with the cycloid. Find the area under one arch of the cycloid. X is equal to r theta minus sine theta, y is equal to r1 minus cos theta. So for this, you need to know that what are the values of theta to complete one arch. To complete one arch, you need to know the value from here, theta for this point and for this point. How do you know these 2 points? How do you find the value of theta for these 2 points?
मैम ये वो वर्टिकल टेंजेंट से नहीं आई थी?
लेकिन अगर वर्टिकल टेंजेंट्स के चक्कर में हम लंबे चक्कर में ना पड़े तो वैसे ही अगर हमें ये करना हो तो कैसे पता चलेगा? How will you know? How will you find the limits of theta?
हम डायरेक्ट वैल्यूज पुट कर दें 0
Direct
0
values. हाँ 0 0 पुट करते, 0 कहाँ पुट करेंगे? यहाँ पे
y की जगह
y की
0 पुट
वैल्यू
करें।
0 है, यहाँ पे y की वैल्यू 0 है, so I will put 0 over here. So r cannot be 0. It means cos theta is equal to 1, theta is equal to 2 n pi, even multiple. So it means these points are 2 pi. The values of theta for these points are 2 pi, 4 pi, 6 pi. And when I put n is equal to 0, I will get this point. So I have to find the arc length for theta is equal to 0 to 2 pi. I can also take the limits from 2 pi to 4 pi or 4 pi to 6 pi. But if I have the value from 0 to 2 pi, the calculations would be much easier. So over here, I have to put dy dx. What is my y? My y is r1 minus cos theta. And what is my dx? Dx is r1 minus cos theta d theta. r1 minus cos theta d theta. So I will get r square, which I can take common. So 1 minus cos theta whole square d theta. Now you need to integrate this 1 minus cos theta whole square d theta. How will you integrate it?
मैम स्क्वायर ओपन कर देंगे फिर आगे सॉल्व कर देंगे।
Yes, open the whole square, expand the whole square, and then simplify it. Open the whole square. We will get 1 minus 2 cos theta plus cos theta whole square, cos theta square. And then you can apply 1, instead of cos square theta, you can write 1 minus cos 2 theta, half angle identity. Then integrate it simply. So you will get 3 pi r square. So it means 3 times the area of the rolling circle. 3 pi r square. This is the area under this arch. 3 pi r square. Okay. Now arc length. How will you find the length of a curve C, which is given by this? Do you remember the formula for arc length? This is the formula for the arc length or length of a curve given by y is equal to f of x. Now we have to convert this formula into for parametric curves. So for parametric curves, क्या बनेगा जरा निकाल के दिखाएं. क्या बनेगा? dy by dx is equal to dy by dt dx over dt whole square. And what is your dx? Dx is, by using chain rule, dx over dt dt. The limits of t are from alpha to beta. Now simplify it and tell me what will you get after simplification. Take the LCM and then cancel it with the term dx over dt.
Ma'am, dx over dt whole square plus dy
Hmm.
over dt whole square under root.
Under root, and this one dx over dt whole square plus dy over dt whole square under the root dt, and limits are from alpha to beta. Okay, dear students, now again we have to apply this to the cycloid, but before that let's see if we find the length of the circle. X is equal to cos t and y is equal to sin t, and t is from 0 to 2 pi. In this case we have to first find the derivative dx over dt and dy over dt, and simply put it in this formula, this, and then this. And for the other example, x is equal to sin 2t, y is equal to cos 2t. What would be the length of this curve? Do we need to take the limits from 0 to 2 pi? If we are supposed to find the length of this curve, do we need to take the limits from 0 to 2 pi or other than these?
0 to 2 pi होगी मैम, I think.
0 to 2 pi अगर हम करते हैं तो आपके पास ये लिमिट आ जाती है 4 पाई के इक्वल आ रही है, क्योंकि सर्कल की लेंथ तो आपके पास, सर्कल का रेडियस ऑफ द सर्कल इज 1, so you will get 2 pi. Logically you will get 2 pi, but here you will get 4 pi. Why? Because circle is
मैम वो तो
transversed
the
twice, traced twice, but if you have to find the length of the circle, you have to take the limits from 0 to pi. You have to take the limits from, so you have to be careful about that, because the integral gives twice the arc length of the circle. In general, finding the length of a curve C from a parametric representation, we have to be careful to ensure that C is traversed only once as t increases from alpha to beta. So we have to be careful about taking the limits, that is, the curve is traced only once. If we are supposed to find the length of the curve, तो फिर हमें उसकी limits देख के लगानी है. What about the length of the arch of the cycloid? Okay, now do this question. Find the length of one arch of the cycloid. The formula is given. The limits, the arch is completed. Theta is from 0 to 2 pi. One arch is complete. So you have to find the length of this arch from here to here. That is, you have to take the limits of theta from 0 to 2 pi. 0 to 2 pi y dx. Sorry, this is not y dx. This is dx over dt whole square plus dy over dt whole square into dt. Okay, find dx over dt, square it, and add it to dy over dt whole square, and then integrate. What will you get?
मैम जो आपने
जी
मैम जो आपने बताया वो एक दफा होना चाहिए साइकिल, तो हमें पता कैसे चलता है कि एक दफा साइकिल आ रहा है कि 2-3 दफा हो चुका है, वो कैसे पता चलेगा?
आप स्केच करेंगे, because for finding the areas, arc length and tangent lines, these questions cannot be done unless you sketch the figure. स्केचिंग के बगैर आप काम नहीं कर सकेंगे, आर्क लेंथ का भी, टेंजेंट लाइन का भी और उसका भी। इसी तरीके से पोलर कोऑर्डिनेट्स पे जब हम
तो मैम वो
करेंगे,
जीरो
तो पोलर कोऑर्डिनेट्स में भी you have to sketch the curve, whether you are finding the tangent lines, areas under the curve, polar curve, or the length of the polar curve.
0 से 2 पर जो पॉइंट्स आएंगे सारे, उन फिर पॉइंट्स को प्लॉट करके कर्व बनाएंगे ऐसे ही।
जी बिल्कुल, जैसे हमने पिछले किया था।
ठीक।
मैम आपकी आवाज नहीं आ रही।
So what's your answer?
आवाज ही नहीं आ रही मैम आपकी।
जी स्टूडेंट्स, आवाज आ रही है कि नहीं आ रही अभी?
मैम अब आ रही है, को पिछले 2 मिनट से नहीं आ रही थी।
ठीक है, 2 मिनट्स में मैं यही पूछ रही थी कि व्हाट इज योर आंसर।
मैम 8R आ रहा है आंसर।
8R है, गुड, ये 8R इसका आंसर है। So 8R is the length of one arc of the cycloid. So this is all done about this parametric curves and calculus with parametric curves. And for this, you know the formulas for the tangent line, for the arc length, and for the area under the parametric curve. So in the next class, inshallah, we will start the polar coordinates, and for polar coordinates, I have uploaded a file. I think we will start the sketching of the polar coordinates in the next week. So in polar coordinates, basically, we will see what is the polar coordinate system, how to convert Cartesian coordinate system in equations in Cartesian system into polar coordinate system, and then vice versa, and then how to sketch the polar coordinates, their symmetry,